So in this video here, we're going to take a look at how we can do image classification with the YOLO11 model on the CIFAR-100 dataset. So this is very much just a dataset containing a bunch of different classes. Like we have 60,000 images divided into 100 classes. So when we do image classification, we just take our whole image, pass it through a model, and then we'll get our categories out. Basically just categorize or predict what class this image belongs to. So let's just jump straight into it and see how we can train it with the YOLO11 model. So we're just starting inside the Ultralytics Documentation. If we go inside the Datasets tab, we can see we have this CIFAR-100. We also have all the other different datasets in here, both for update detection, segmentation, post-estimation, classification, and also RNA bounding boxes. We have a couple of videos covering some of these datasets for the different tasks. But we have our CIFAR-100. First of all, we can read about the key features. So it has like 60,000 images divided into 100 classes. Each class contains 600 images, so that's a lot of images. You can also use your own custom datasets. We just need to have the folder structure where each folder contains the images for the class that we want to be able to do classification of. So we see that the images, they're colored and the size 32 by 32 pixels. So when we're doing image classification, we don't really need that high resolution. Again, we can also check out some of the other ones like ImageNet and so on, but we can get away with low resolution because we just want to categorize or have one prediction for the whole image and not draw bounding boxes as we're doing with object detection. So we can see the dataset structure, applications of it, and also how we can use it. Here we can see some sample images and annotations. So for example, we want to predict airplane or classify airplanes, automobile, bird, and so on. We can see what it is in the image, but it's very low resolution, but the models will still be able to pick up what it is and classify them. So I'm just going to grab this code. We can either use it in Python or from the command line. Right now I'm just going to show you how we can do it in Python. Just go in, open Google Colab Notebook. I'm going to connect to a runtime so you can specify which GPU you want to use in Google Colab. We have videos covering like the free features and so on. I'm just going to use the A100. The T4 is on the free version. And we can train all the Ultralytics stuff and so on, either in the Ultralytics Hub or in the Google Colab Notebook. So first of all here, we just need to pip install Ultralytics. There we go. If you run into any errors or problems, it might be because you don't have the latest version of Ultralytics, especially if you want to use the YOLO11 models. We connect to the runtime, we can go in and pip install Ultralytics, and then we just need to throw in these couple of lines of code, and it's going to train the model. So first of all, let's just divide this into different blocks of code. It's going to download it, and it's also going to pull the dataset automatically. We have tons of videos covering like how you can train it on your own custom dataset. You just need to have your data in the correct format and you can use it in the exact same way. So right now we just take our YOLO11 nano model, specify -CLS for classification. That's pretty much it. It's going to load the pre-trained model, download automatically the first time we run this program. There we go. Now we can see it's going to install it and it will be into our directory on the left. There we go. So now we have downloaded the model, we've initialized it, and we can call the train function on top of that. The dataset that we're going to use is the CIFAR-100. Let's just train it for 50 epochs with an image size of 32. We can also specify the batch size and so on, but all of these arguments and parameters, they can be found in the Ultralytics documentation. So right now, let's just go with the default parameters. Normally pretty good when we're just training our models. Let's just start the training, and that's pretty much it. It's going to download the dataset to start with, set up the whole training with all the high parameters, the optimizer and all that, and we will see the training results live here. We found 50,000 images in 100 classes, 10,000 images in 100 classes for our test set, so the exact same as in the documentation. Right now it's just scanning through it, taking a look at all the labels and so on to make sure that they are correct and loading it in. So scanning the dataset, 45,000 out of 50,000. There we go. We have our validation set as well. We set up our optimizer, tensor board, and it has now started the training. So right now it's just going to take all the data, 50,000 images, throw it through our model, optimize our model, and it's going to do it 50 times for each epoch. Then we can take a look at the results after and also how our model performs. So our model is now done training after roughly an hour. And if we take a look at it, we can see that we get our losses. We also get our top 1 accuracies and also our top 5 accuracies. If you just go a bit further down, again, we can go in and take a look at the results from all the training graphs in the run directory. So So we should probably just do that. Here we can see the validation as well. So the top 1 accuracy, so around like 40% accuracy for top 1, which means that every time we pretty much make the correct prediction. Top 5 is that our classes act like in the top 5 out of the 100. But again, we want our top 1 accuracy as high as possible, because again, we want to be able to predict the exact class every single time. So if we go inside our runs directory, classify, you can see we have a train folder. We can go inside our results.png and we'll be able to see all the train graphs instead of the output here. So we can see our losses and we can also see our accuracies. We have pretty much converged, but again, this is a very large data set. Like we have hundreds of different classes. Like if you only have a few classes and so on, you're going to get much better performance. So you're going to take a look at the results here. Losses haven't fully decreased yet, but the accuracies look pretty good. And we can also go and take a look at our confusion matrix. So we have all the classes here. We have our predictions on this axis and the ground truth on the x-axis here. So again, ideally we want to have all the values here in diagonal. We can go in and see, okay, what classes do we have problems with and so on. In general, it looks pretty good in the diagonal, but we can see we get some false prediction, especially like around here where we predict like 48, 47 or whatever. We need to dive more into details with that, because again, we have 100 classes to take into account. But this is how we can train a YOLO11 model on a custom dataset, or pretty much any dataset. You can use the ones from Ultralytics. In this video, we use the CIFAR-100, 100 different classes, 60,000 images. So this is a very large dataset. We only need to have the folder with individual categories. You can get away with just a few hundred images for your own datasets. Train it, use it in your own applications, and that's pretty much it. Thanks a lot for watching this video here, guys. I hope you learned a ton. Definitely go and check it out. It's just a few steps that we need to do, and then I'll just see you guys in one of the upcoming videos. Until then, happy training.